Alright, today we tackle 1.2, the method of substitution. You already know about linear systems, right? A linear system is a system involving two or more linear equations, two or more lines. And what does it mean to solve a linear system? Yeah, find the points of intersection. So here's a linear system, and there's our point of intersection. And if we're going to solve this linear system, that means our answer is either going to be in the form of x, y, the coordinates of that point of intersection, or our answer can be in the form x equals something, y equals something. Okay, so if we went through a problem and we found that the point of intersection was the point 2, 3, this would be a suitable final answer, or this would be a suitable final answer. Okay? So solving a linear equation, solving a linear system of linear equations, basically just means we're finding the point of intersection. Method of substitution means solving a linear system, by substituting for one variable from one equation into the other equation. So we're solving, yesterday we solved linear systems by graphing them. We graphed them and then we looked and we found their point of intersection. This time we're doing it more mathematically, more algebraically. You're just finding one variable, subbing it into the other equation, and that will make a lot of sense once we go through our first example. So, example 1. Example 1, we have the lines y equals negative x plus 8 and x minus y equals 4. And it tells us that they intersect at a right angle. Do we need to know that they intersect at a right angle? No. We really don't. We just need to find where they intersect. We don't need to know how they intersect. That has to do with the slopes, and it'll be valuable as we move through the units. But in this case, it's called extraneous information. It's information that we don't need. Our job is just to find the coordinates of the point of intersection. So find the point of intersection. And they've asked for it in coordinates. So when I get to my final answer, I'm going to make sure that it's in the right form. I'm going to make sure that it's actually in coordinate form, that it looks like the coordinates. So we have our two lines. What's my first step? What do I want to do with those two lines? How about write them nice and neatly and organized? I'm going to label line 1, y equals negative x plus 8. And we'll label our second line, x minus y equals 4. Now, equation 1 is already in a very helpful form. Equation 1 already says what y is equal to. Now I know, like we talked about before, that where these two lines intersect, x and y in the coordinates are going to be the same. So this x is going to be equal to this x, and this y is going to be equal to this y, only where they intersect. Okay, there's only one possible point where they will intersect, and the x and y's will be the same. So what I can do is I can take this y from equation 1, and since it equals negative x plus 8, I can actually just sub it right in to equation 2. So I haven't changed anything else about equation 2. It still has an x, still has a minus sign, but now instead of y, we have in brackets negative x plus 8, and it still is equal to 4. Now look at what's happened. We've eliminated one of the variables. Now we only have x in the equation, and we can continue to use our algebra skills to solve for x. Okay? So step 1, substitute one value for another. So substitute for one of the variables. Step 1, if you want to just write what we did, we substitute for one of the variables. We substituted for y, and now we have x's by itself. Okay?
Question number 4, is it every single question? Or
Okay, so now that we have this reduced, now that we have just one variable, x, we can solve for x. So what we want to do here first is deal with what's inside the brackets here. It has a negative outside. It's kind of like an invisible -1 outside the brackets. So we need to distribute that to our negative x and to our positive 8. And so the next row is x, and -1 times negative x is plus x. -1 times 8 is -8 equals 4. Let's put our x's together. We've got 2x, and let's add 8 to both sides. So 2x equals 12. Our next step is to divide both sides by 2.
Does it really matter what you divide by?
Yep, we must.
It's into the other side.
We have to divide by 2 because we have 2x. So then I want to get x by itself. Right, I want to find out what x is. Right now I have x here, and I have x here. So if I divide it by 2, then I get 1x by itself. And if I divide this side by 2, I must divide that side by 2.
What if it was 11?
Then you would have 11 divided by 2, which is 5.5. So x does not have to be a whole number, but good question. Now that we found out what x is, we still need to find the y coordinate. So step 2 is to substitute back into step 2, sub x equals 6 into, it doesn't matter what equation, but we'll use equation 1 to find y value. So equation 1 says y equals -x plus 8. We know that x equals 6, so we have -6 plus 8, which means when x equals 6, y equals 2. So we can assume so far, not assume, but we believe so far that x is equal to 6 and y is equal to 2, but we need to check our answer. Step 3 is check our answer. Step 3, check your answer in both original equations. Check your answer in both original equations. So I'm going to erase and move up to the top. And we're first going to deal with equation 1, which was y equals -x plus 8. The left side is y, and the right side is -x plus 8. And if the 0.62 satisfies the equation, then both left side and right side should be equal at the bottom. If 6,2 satisfies the equation, left side should equal right side once we're done here. Well, in the coordinates 6, 2, y is equal to 2, so our whole left side just reduces to 2. And our right side, we sub in 6. For x, we have -6 plus 8, and that's 2. So we can say our conclusion left side equals right side. Well, let's see if this is also true. That means that the 0.62 is on the line y equals -x plus 8. But in order for it to be the point of intersection, it has to be on both lines. So the second line that we were dealing with was x minus y equals 4. So here the left side is x minus y, and the right side is 4. So if 6, 2 is on the line, it will satisfy this equation, and we will get left side equals right side. X was 6, y was 2, and that equals 4. So our final statement, left side equals right side. Because the point 6, 2 satisfies both equations, we can say, therefore, the point of intersection, the POI, is 6, 2. That's the fourth step, writing our conclusion. Okay, example 2. Find the solution to the linear system. Remember, a linear system is a group of 2 lines or more. And to solve it, to find the solution, means to find the point of intersection. So we've been given our 2 lines, and we're going to use the method of substitution. So the first thing we have is to label both of our equations. 2 lines. Okay, we don't know what they look like. It doesn't matter that we know what they look like. We know that they're going to intersect. Step 1 was to substitute one for the other. But if you look, I don't have anything that I can easily substitute. I don't have y in terms of x or x in terms of y in either of these equations. I need to have y on one side equals yada 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 on the other side in order to use substitution. So all I'm going to do first, step 1 here, is I'm going to rearrange equation 1 so that instead of x plus y equals 5, I can subtract x from both sides, and I'll get y equals 5 minus x. Now I have what we call y in terms of x. I know what y is, not exactly, it doesn't have an exact numerical value, but I know y in terms of x. Y is 5 minus x. And what we said before is that if y is 5 minus x in equation 1, then y is also 5 minus x in equation 2, where they intersect. So that's why this is such a helpful thing. It's only true right where they intersect, which means if I substitute it in, the only possible point I'm actually going to find is the point of intersection. We'll head to step 2 here. Step 2 in this situation is substitute. So here's our new equation 1. We know what y is in equation 1, so we're going to sub it into equation 2. We still have 3x. We have minus y, but instead of y, we're going to write 5 minus x, because we know that that's the exact same as y. Step 3, solve for x. So we're just going to carry on with this equation and solve for x. So we've got 3x minus, this is like an invisible 1 out front, right? So we're distributing. Negative 1 times 5 is negative 5. Negative 1 times negative x is positive x. Let's group our x terms. So we have 4x, and let's add 5 to both sides. 4x equals 12.
Which line is that? Which line is it?
This is not, we got this starting with line 2, but now we're just solving for x. So once we get x, that's going to be the x value of the coordinates of the point of intersection. So here we just divide both sides by 4. X equals 3. Okay, so we know that x equals 3 at the point of intersection. So step 4, I just need to substitute x equals 3 into both of my original equations. Well, one of them first. So step 4, sub x equals 3 into, let's pick equation 1 because it looks prettier. It's easier to work with. to find y. So here we go. We've got equation 1. We've got x plus y equals 5. We know x is 3. So now in order to find out what y is, we just need to subtract 3 from both sides. Y equals 2.
So you think your x is 3 and your y is 2?
So we think that our x is 3 and our y is 2. We know that's true in equation 1, so let's go step 5. Let's check in equation 2. We've got 3x minus y equals 7. Left side equals 3x minus y. Right side equals 7. So if we sub in our values for x and y and we get 7, we know left side will equal right side. X we believe is 3. Y we believe is 2. So we have 9 minus 2, which equals 7. Therefore left side equals right side.
Why don't we check number 1?
We already did, right, in this one. We subbed it in to find x and y. So we already know that it works in number 1. So then we check in number 2. It works. The point. Sorry, we're not looking for the point of intersection. We're looking for the solution. The solution is x equals 3, y equals 2. Example 3, we're going to find the point of intersection between two lines using substitution. Same as before, our lines are just slightly more difficult. But here we go. I have my two lines, 2x minus y equals 4, and 4x plus y equals 9. I'm going to go ahead and label them line 1 and line 2. And because we're using substitution, it means I want to express one of the variables in terms of the other variable. So I want one of the variables by itself on the left with all the other stuff on the right, and then I can take that variable and substitute into the other equation. Okay, which equation would you like to rearrange, and which variable would you like to isolate? Should we try to get x by itself on one side?
Y.
Or should we y by itself? Of course. And which one are we going to use?
Y, because we want to use the positive y.
So we could use equation 1 and add y to both sides and then subtract 4 from both sides. That would be good. This one looks a little bit easier. Y is already positive. So all I need to do to get y by itself is to subtract 4x from both sides. So I'm going to take equation 2 down here, which says 4x plus y equals 9. I am going to subtract 4x from both sides. That's going to give me equation 2. As I have been fair, I used my balance. I'm balancing both sides by doing the same thing to both sides. So y is equal to 9 minus 4x. Now, when we typically write a final answer, if the equation of the line is our final answer, we would write y equals negative 4x plus 9. That would be in slope-intercept form. I'm not going to do that this time because I'm actually using this information. I'm going to sub it into equation 1. So now here's equation 1. Everywhere I see a y, I'm good to sub in 9 minus 4x because 9 minus 4x is the exact same value as y. So 2x minus, and then watch here, I'm throwing it in brackets. Okay? 9 minus 4x, close bracket, equals 4. Okay? Now I'm going to simplify this, and I'm going to solve for x. That's going to give me the x coordinate of the point of intersection of these two lines. Okay?
I don't know how that works though.
Here we go. 2x, and here I have to distribute this negative to both terms inside the bracket. So we've got a negative 9 and a positive 4x. I can rewrite that sentence. 2x minus 9 plus 4x equals 4. Now I can group my x terms And in the same step, I'm going to add 9 to both sides. That will give me my variable terms on the left and all my other values on the right. Okay, 2x plus 4x is a total of 6 x's. Over here, my negative 9, positive 9, that's 0. And over here, 4 plus 9 is 13.
Divide the 2.
Divide both sides by 6.
Don't forget a decimal.
I get x equals 13 over 6. Now you might think, oh, I did something wrong. That's a funny number. 13 over 6 is just a number, just like any other number. Okay, I'm not going to round this into a decimal, because if I round it into a decimal and then use it again, then my next answer will be even further from the truth. So I'm actually just going to leave this. This is my x coordinate of the point of intersection. Now how do we find the y coordinate that goes with this x coordinate?
Wait,
Number
Rise over
1.
red.
No, y. 1. We haven't
Yeah.
done 1. We've only
Why
done
would do the same minus y2?
I can actually sub this value into either equation. It does not matter which equation, because look, they share this point. So whether I'm in equation 1 or equation 2, it doesn't matter. The x that I found will match with the y that belongs to the point of intersection. Okay, I'm going to go ahead and sub it into equation 2, because equation 2 I've already rewritten in a nice little y equals 9 minus 4x. Okay, so I'm going to sub x equals 13 over 6 into equation 2 to find the y coordinate. I'm going to scroll down a little bit here. We've got equation 2 is y equals 9 minus 4x, but where I see an x, I'm going to sub in what I know x is equal to, 13 over 6. Okay? Now I have y equals 9 minus, and here I can kind of do this all at once or step by step. Either way, I'm going to, what I could do is reduce these guys. I could divide the numerator and the denominator by 2. That would give me a 2 here and a 3 here. Or I can multiply it out and then reduce.
Wait, I'm so confused.
I am so
It's okay, right now I just have simply a fraction times another fraction, right? This means multiplication.
Where'd you
So I
get
have
the 9 from?
equation 2.
Also,
But how'd you drop the x?
Can you stop?
Yeah, I
X equals 13 over 6. I didn't drop anything, it's right here.
Oh, okay. Oh,
Okay, I'm going to continue on. You can ask questions in a second.
Yes, sir.
Okay, 4 times 13 is 52 over 6.
Whoa,
52
50.
Yeah, because it
over
times
6. And because these are both even numbers, I know I can divide them by 2. So this is going to be 26 over 3.
Mr. E, why did you do it 4 times?
And because I am subtracting fractions, I can need to find a common denominator. I have a common denominator of 3, so I need to represent 9 as a fraction over 3. Right now it's 9 over 1, so that's the same as 27 over 3. Becomes pretty easy. Y is 27 thirds minus 26 thirds. Y is 1/3.
33.333.
Okay? So the solution here, the point of intersection, the lines intersect
at 13, 6, and 1.
This is why we couldn't figure out.
at the point 13 over 6, 1/3. Okay, x coordinate, y coordinate, that's this point right here where they intersect. So it's a little bit more challenging than the other ones because it uses fractions. You follow the exact same steps, do it carefully, you will make it.
That's what he did in this.
Example 4, we'll jot down some of the information that we have. It's a word problem that we're going to be solving a system of linear equations. We have Stephanie has 5 more fish than Brett. And I'm just kind of summarizing the information. Steph has 5 more fish than Brett. Together, they have
Two negatives.
31 fish.
Now, is it just two? Now to find
The
out
question is, how many
times 4 is negative.
fish
Then you take x,
does
x,
Steph have?
because you want positive x, so that makes it nothing. It's still negative.
And
So it's negative.
how many fish does
Two negatives to make it
Brett
positive.
have?
So whatever the answer is, it's going to be positive. Then x,
So we know that Steph has 5 more than Brett, and we know together they have 31 fish. So right there's our 2 equations in those sentences. But let's introduce some variables first. Let's let
no,
S
0.
represent Steph,
You need to get rid of this.
and let's let
This
B
x. X is right here.
represent
Add x.
the number
With zero. This
of Brett's
equals
fish.
x. 2 divided by x.
Why
X is the
number?
So let's do that with Steph too. Let S represent the number of Steph's
These are two negatives.
fish. So we want to know how many fish they each have.
Look, x, that's a positive. That equals this.
Can you guys
So that's,
take it down
still
just a little bit?
negative.
Okay, so our 2 equations. From the first sentence, Steph has 5 more fish than Brett. So whatever Brett has, Steph has 5 more. So Steph has Brett plus 5. The second equation says that together they have 31. So S plus B equals 31. And that's just translating our words into algebra. Well, now we have 2 equations and 2 variables. The variables are S and B, and the 2 equations are right there before us. So we can use our skills of substitution to solve this problem. What do you think I should do? Yeah, we already have equation 1, S in terms of B. So let's just sub B plus 5 into equation 2 wherever we see S. Right? So we've got, instead of S, we're going to write B plus 5.
Okay, but then you have to do the second part.
Yeah, I know.
Still plus B equals 31. And now we just solve for B. We have 2B plus 5 equals 31. Subtract 5 from both sides. 2B equals 26. B equals 13. What does that tell us? That tells us that Brett has 13 fish.
3, right?
So let's find out how many fish
This equation is done.
Stephanie has if Brett has
So 3
13 fish.
times 2.
S equals
No, you can't do that.
13 plus 5. Steph has 18 fish. Go ahead and finish that off with a conclusion statement and sentence.